Welcome, my friends! You've most likely solved equations like this, where you have a variable in the denominator. The way to solve for x is to multiply both sides of the equation by x. This will cancel the x from the denominator on the right-hand side. This leaves us with negative 9x is equal to 6. From here, we can simply divide each side by negative 9 to get x is equal to negative 6 over 9. Of course, negative 6 over 9 can be reduced to negative 2 over 3. So our final answer is x is equal to negative 2 over 3. What about 3 over x is equal to 15 over x plus 14? Well, this is the same type of idea, but we just have x in two places. We can still multiply everything by x, but we just can't forget that the 14 on the right-hand side will also get multiplied by x. This will cancel the x on the first two terms. We'll have just 3 and 15 as the x's canceled. But then we must distribute the x to the 14, which gives us 14x. If we subtract 15 from both sides, we have 3 minus 15, which is equal to negative 12 on the left-hand side. Dividing both sides by 14, we have negative 12 over 14, which can be simplified to negative 6 over 7, and that is our final answer. If you have something like this, with an expression involving x plus a constant, you can use the same exact process to solve for x. The only difference is, now you need to multiply both sides not just by x, but by x plus 7. This will cancel the x plus 7 from the right-hand side, and leave us with negative 5 times x plus 7 on the left-hand side. We can distribute the negative 5 to the x and the 7, which will leave us with negative 5x minus 35 on the left-hand side, and negative 2 on the right-hand side. Then we can add 35 to both sides to cancel the 35, leaving us with negative 5x is equal to 33. Dividing each side by negative 5, we have x is equal to 33 over negative 5, or simply negative 33 over 5. Let's try this one, where we have x minus 4 in two different denominators. One way to solve this would be to move both terms with x minus 4 to the same side of the equation, and then combine the fractions. But I think a little bit of an easier way is to use the same process we used in the last problem, which is to just multiply both sides of the equation by x minus 4. Now, since we have an additional term of 6 on the left-hand side, it will also need to be multiplied by x minus 4. The two terms with x minus 4 on them will both have cancellations, and we will be left with 6 times x minus 4 plus 4 is equal to x. Now we need to distribute the 6 to the x minus 4. This gives us 6x minus 24 when we distribute, plus 4 on the left-hand side. Combining the constants of negative 24 and 4, we have 6x minus 20 is equal to x. Subtracting 6x from both sides to cancel the 6x, we have negative 20 is equal to negative 5x. Dividing each side by negative 5 to cancel the coefficient on x, we have x equals 4, which is our final answer. But wait just a minute. Notice that in our original equation, we had x minus 4 in the denominator. If x equals 4, that would make the denominator 4 minus 4, which is equal to 0, and we know that we can't divide by 0 in math. That means x equals 4 is not actually a solution, as we can't plug it back into our original equation. For this reason, we say that this problem has no solution. Let's try negative 6 over x is equal to negative 14 over x minus 4. If you have two fractions set equal to each other, you can cross multiply, which is just a fancy way of saying multiply both sides of the equation by the denominator. If we cross multiply, that means we should multiply negative 14 by x, and we should also multiply negative 6 by x minus 4. This will give us negative 6 times x minus 4 on the left-hand side, and negative 14x on the right-hand side. Negative 6 times x minus 4 can be simplified to negative 6x plus 24. We can add 6x to both sides to cancel the 6x, which gives us 24 is equal to negative 8x. Dividing each side by negative 8, we get x is equal to negative 3. Looking back at our original problem, it does not appear that x equals negative 3 will cause any divide by 0 errors, meaning that x equals negative 3 is our solution. How about 6 over 5x is equal to 1 over 15, minus 7 over 3x. The best way to simplify this is to multiply by the least common denominator of 5x, 15, and 3x. Hopefully you can verify that the LCD will be 15x, as 15x is the least common multiple of 5x, 15, and 3x. Multiplying everything by 15x, the 15 and the 5 simplify to 3 on the left-hand side, and the x's cancel. This leaves us with 3 times 6, which is just equal to 18 on the left-hand side. For the first term on the right-hand side, the 15's cancel, and we are left with just x. For the second term on the right-hand side, 15 over 3 is 5, and the x's cancel, which leaves us with negative 7 times 5, which is negative 35. Now we can add 35 to both sides of the equation to get x is equal to 53, which is our final answer. Let's try 8 over 4x minus 24 minus 1 is equal to 2 over x minus 6. This one might seem a bit tricky, but it's actually very similar to the last one. The first thing to notice is that we can factor the denominator of our first term. If we pull out a 4, we will have 4 times x minus 6. Now we notice that the LCD is just 4 times x minus 6. So we can multiply each term by 4 times x minus 6. On the first term, we cancel the denominator completely, which leaves us with just 8. On the second term, we simply get negative 4 times x minus 6, as we are multiplying 4 times x minus 6 by the negative 1. On the right-hand side, the x minus 6's cancel, but we still have the 4, which we must multiply by the 2. That leaves us with positive 8. We can distribute the negative 4 to the x and the negative 6, which gives us negative 4x plus 24. We can combine the 8 and the 24 to get 32. Next, we can subtract 32 from both sides to get negative 24. Then we can divide each side by negative 4 to get x is equal to 6. But wait, if we look back at our original equation, x equals 6 won't work, as that will make the denominator 0. Therefore, x equals 6 is not a viable solution, meaning there is no solution to this problem. Okay, one last problem. We have 5 over x squared minus 7x plus 12 is equal to 1 over x minus 3 plus 2 over x minus 4. The first step will be to factor the denominator on the left-hand side. We need two numbers that add to negative 7, the coefficient on x, and multiply to positive 12, our constant. Wouldn't it be nice if the two numbers were negative 3 and negative 4 to match the factors on the right-hand side? Well, it turns out the problem is rigged, and it really is negative 3 and negative 4. Negative 3 and negative 4 add to negative 7 and multiply to positive 12, which is going to make this problem a lot easier to solve. The denominator of the term on the left can be rewritten as 5 over x minus 3 times x minus 4. That means the LCD is x minus 3 times x minus 4. So we multiply both sides of the equation by x minus 3 times x minus 4. This cancels the denominator completely on the left-hand side, leaving us with just 5. On the first term on the right-hand side, the x minus 3's will cancel, but we still have x minus 4. On the second term on the right-hand side, the x minus 4's will cancel, but we will still be left with an x minus 3, which will need to be multiplied by the 2. We can distribute the 2 to the x and the negative 3 to get 2x minus 6. We can combine the x and the 2x to get 3x, and then we can combine the negative 4 and the negative 6 to get negative 10. Adding 10 to both sides, we get 15 is equal to 3x. Dividing each side by 3, we get x is equal to 5. Glancing back at our problem, the only values that would not be allowed for x are 3 and 4, meaning that x equals 5 is a valid solution. Alright, my friends, that completes our video discussing solving rational equations.